Hi everyone. Now continuing the order statistics lecture, and this is our lecture number 6 on order statistics. And in this lecture, we will see some questions from some competitive exams. The first question for today is let x1, x2, x3, x4, x4 up to x9 be the order statistics corresponding to a random variable or random samples, not random variables, or random samples of size 9 from uniform 0, 1. Then which of the following is true? That's expectation of x9 given 1 minus x9 is finite. B. Expectation of x5 is equal to 1 by 2. C. Mode of x5 is equal to 2. D. Median of x5 is also equal to 1 by 2. C. The question is, we have the random samples, 9 random samples from uniform 0, 1. Then which of the following is true? Now, talking about the uniform distribution, that's f of x is equal to 1 when x is between 0 and 1, and as you know, x follows uniform 0, 1. Then xr will follow beta r comma n minus r plus 1. Clear? So from here, x1 will follow beta. What's r is 1, n is 9. So 9 minus 1 plus 1, that is follows beta 1 comma 9. Clear? Then x5 will follow beta 5 comma 5. 5 comma 5. Now, and what's x9? X9 is maximum order statistics, that largest order statistics that will follow beta 9 comma 1. And also 1 minus x9 will follow beta 9 comma 1. Those who are new on this video, please go through the previous video of order statistics. जो ये लेक्चर पहली बार देख रहे हैं, उनको चाहिए कि वो पहले लास्ट लेक्चर देख के आए. दैट्स ऑन ऑर्डर स्टेटिस्टिक्स. सी, ये हमारे पास पूरा चीज है. वी हैव दीज थिंग्स, राइट? वी हैव दीज थिंग्स. सो इन्हीं चीजों से हम अपने क्वेश्चंस को सॉल्व करेंगे. ठीक है, अपने क्वेश्चंस को सॉल्व करेंगे. Now let's find the expectation of x9 1 minus x9. तो ये होगा 0 to 1 x 1 minus x into f of x9 dx, which is equal to x 1 minus x, this is 0 to 1 upon beta 9 comma 1 x8 1 minus x 0 dx. So which is equal to 0 to 1 x9 1 minus x 1 upon beta 9 comma 1 dx. And whenever we find this integral, this will tend to infinity. So this is not finite, which is our false statement. This is our false statement. Now see, Focusing on x5, this is beta 5 comma 5. See, this is symmetric. This is symmetric. X5 comma 5 is symmetric. So whenever some random variable is symmetric about some point, then the mean mode median is equal. Mean mode median is equal. So let's find the expectation of x5 only. What will be the expectation of x5? That is 5, 5 plus 5, that is 5 by 10, which is equal to 1 by 2. So this is our true statement. This is our true statement, and this will be our also true. This will be our also true. So these three are true and this is false. So see, whenever distribution is symmetric, then mean mode median is always equal. Like if we talk about a normal distribution, standard normal distribution, or we can talk about the Laplace distribution, these distributions are symmetric about some point, about some mean, about some point, then the mode mean median is always equal. Mean mode median is always equal, right? Mean mode median is always equal. Mean mode median is always equal. Now see, another question is, let x comma y comma z be independent uniform distribution, or be independent uniform random variables on the interval 0 comma a. Let w is equal to minimum of x comma y comma z. Then what is the expected value of 1 minus w by a square? So see, the question is, we are given with the random variables which are independent on the interval 0 comma a, and let w is equal to minimum of this. What is the expected value of this? 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 So now, what's f of x? That is 1 upon b minus a. That's what's b? B is a. 1 upon a minus 0. This is equal to 1 upon a when x is from 0 to a. This is my f of x. Then what's f of x? Capital F of x, which is equal to x by a simply. This is the CDF. Now, what is the distribution of minimum order statistics? Let's G of W. That is, as you know, I told you about the f of xr. That is n factorial upon r minus 1 factorial n minus r factorial f of x r minus 1 f of xx 1 minus f of x n minus r. Clear? So see, from this we can write here that n is equal to 3. This is 3 factorial. R is equal to 1. So 1 minus 1 is 0 factorial, and n is 3. 3 minus 1 is 2 factorial. And what's f of w? F of w is x by a. That's r minus 1. R is 1 minus 1. That's 0. That's 1 minus 1 is 1 minus 1 is 0. Then what's f of x? This is 1 upon a. 1 minus x by a. N minus 1, that's 2. So this is equal to g of w is equal to 3 factorial. 3 into 2, 6. 6 divided by 2 is 3. 3. This is 0. 0. Anything raised by 0 is 1. So this is 3 by a. 1 minus w by a square. 1 minus w by a square. One minus w by a square. So this is g of w. This is g of w. This is g of w. And then find the expectation of 1 minus w by a. So this is equal to 0 to a 1 minus w by a into 3 by a 1 minus w by a whole square. So this is 0 to a 1 minus w by a whole cube upon 3 by a dw. So you find this, then you will get the answer, right? You will get the answer. Now see, another question is, if the marginal probability density function of kth order statistic of a random sample of size 8 and from uniform 0, 2 of size 8 of size 8, that's f of x is equal to 7 by 32 x 6. This is 2 minus x, and this is 0 to x. X is between 0 to 2. Then find k. How to solve this question? If the marginal probability density function of kth order statistic, let's find the f of k. Let's find the f of kk. That's f of rr. Simply, this is n factorial. This is 8 factorial. 8 factorial. N minus k factorial. K minus 1 factorial. F of x. This is f of xx. F of xx. F of xx. That is f of xx k minus 1 into 1 minus f of xx n minus k into f of xx. See, compare this PDF with this. This is equal to this. This is equal to 7 by 32. And this is equal to this. This is equal to this. This is equal to this. And this is equal to this. So from here, can you tell me the value of k? See, f of xx k minus 1 is equal to x raised power 7 minus 1. So k is equal to 7. This question is asked in the GATE exam. Right? This question is asked in the GATE exam. So see how easy, from this question, how easy is it to get the 2 marks. Get the 2 marks. Right? It's easy to get the 2 marks from GATE exam. See the question. The question is simply, you are given with the PDF of kth order statistic. Then you have to find the value of unknown, that's k. Now see another question. Let y1, y2, y3, y6 be the order statistics from a random sample of size 6 from a distribution with density function, that's f of xx is equal to 2x. This is between 0 and 1, 0 otherwise. Then expectation of y6. Simply see, whenever you are asked to find the expected value of order statistics, step number 1 is write f of x. Step number 2 is find capital F of x. Step number 3 is find find f of r. I have given you the formula. From that formula you can find the f of r. Then whenever you get the PDF of f of r, then expectation of xr will be easy, variance of xr will be easy. So only you have to follow these 3 steps. So we will do the same. What's f of xx? Okay, f of x is already given. Now what's f of xx? That is 0 to x 2x dx, which is equal to x square. Now n is equal to 6, r is equal to 6, matlab largest order statistics. That's g of y6, that is 6 factorial 6 minus n minus r, 6 minus 6, that's 0 factorial, this is 1, and then r minus 1, 6 minus 1 is 5 factorial, which is f of x, this is x square, r minus 1, r is 6 minus 1 is 5, and then we have 2x, that's f of xx, this is 2x, then we have 1 minus x square raised power n minus r, this is 6 minus 6. Clear? So now in place of x, write y6, this is 6 into 5 factorial divided by 5 factorial, this 5 factorial goes, this is y6 10, 2 5s are 10, then we have 2y6, which is equal to 12y11, this is equal to 12y11. So expectation of y6 will be 0 to 1 y12 by 11 dy, which is equal to 12 y13 upon 13. This is 0 to 1, which is equal to 12 upon 13 is the answer. Now remember, some things are to be remembered only. So let xi follow exponential 1, and for all I is equal to 1, 2, 3 up to so on, or then x3 minus x2. So difference will follow which distribution? And remember, x3 and x3 minus x2 are independent. Whenever you find the order statistics, do one thing, assume that they are independent. Actually they are independent. Then what is the distribution of x3 minus x2? Remember this will follow exponential theta n minus r. So which follows exponential, what's theta is 1, n is 3, minus r is 6. Wait a minute. So this is 3 minus, remember, x r minus x s will follow exponential theta n minus r. So from here x3 minus x2 will be 3 minus 2. This is x r minus xs n minus r. N is 3. This is n minus r. This is r minus 1. 3 minus 1, that's 2. That's 3 minus 2 is this will follow exponential 1. n is 3. 3 minus 2 is 1. Yeah. So similarly, if we have the xi, I is equal to 1, 2, 3, 4, then x3 minus x2 will follow exponential 1 upon 4 minus 2. That is equal to exponential 1 by 2, exponential 1 by 2, exponential 1 by 2, which will follow chi-square 2, chi-square 1, with 1 degree of freedom, with 1 degree of freedom, with 1 degree of freedom. Now see, find the expectation of x3 minus x2 given x2 is equal to 1. How to find this expectation? As you know, x2 and x3 minus x2 are independent. Then we can write this as expectation of x3 minus x2 only, which is equal to, if this is chi-square, which is chi-square, the expectation of chi-square is n, which is equal to 1. This is degree of freedom. So expectation of x3 minus x2 is equal to 1 only. Is 1 only. Is 1 only. And remember, if x follows exponential lambda, y is equal to lambda x will follow exponential 1 and 2y will follow chi-square 2. And remember, this is not the result from order statistics, but you have to remember this: x1 and x2 follow exponential, then x1 plus x2 follow uniform 0, 1. Uniform 0, 1. Now see. Question is, f of x is equal to e raised power minus x, x is greater or equal to 0, and x1 and x2 are IID, which has a distribution exponential. Then x1 is minimum of x1 comma x2 and x2 is maximum of x1 comma x2. Then find expectation of x1 and 2 x2 minus x1 will follow which distribution. So solution hoga k. See, x1 is minimum. As you know, we have already proved when x follows exponential, then minimum will follow n lambda. So x follow exponential 1, x1 will follow exponential 2, lambda is 1. So this will follow exponential 2. This is the result. You can see my previous video. So x1 will follow this. So expectation of x1 will be 1 by 2. Expectation of x1 will be 1 by 2. How this is equal to 1 by 2? As the PDF is 2e raised power minus 2x. So whenever we find the expectation of this, that's equal to 1 by 2. If the PDF is 1 by 2 e raised power minus x by 2, then expectation of x will be 2. So we have this, we have the different PDF, that's 2 e raised power minus 2. So expectation of this is equal to 1 by 2. Clear? Now we have the result from the that x2 minus x1 will follow exponential theta is 1 upon theta is 1 upon, this is equal to 1 upon 2 minus 1, that's 1. So 2 x2 minus x1 will follow exponential will follow chi-square 1, will follow chi-square 1 or chi-square 2. This will follow simply, this is exponential 2, which is chi-square 2. This is exponential 2 will follow chi-square 2 only. So simply x2 minus x1 will follow exponential 1, then 2x2 minus x1 will follow exponential 2, which will follow chi-square 2, So this is the question from 2023 IIT JAM. Now the last question of this lecture is, and this is the most important question. Question is, let x1 up to xn be a random sample of size n greater or equal to 2 from an exponential distribution with PDF f of x comma theta is equal to e raised power minus x minus 2 theta, where x is greater than 2 theta, theta belongs to 0 to infinity. Then x1 is minimum of x1 up to xn, then find expectation of 1 by theta x first order statistics minus 1 upon n given x1 minus x2 is equal to 2. Then define the value of this. See, what's the question? Question is, we have the PDF, that's exponential x minus 2 theta, that's double exponential Laplace distribution. Then we have the first order statistics. Then find the expectation of this quantity. See, don't get scared. Okay, what's this quantity? So see, this is independent. X1 minus x2 and x1 are independent. So we will be only left with expectation of 1 by theta x1 minus 1 upon n. Only we have to find the expectation of this. See, whenever we try to find the PDF of this, that is, this multiply, as you know, probability A given B is equal to probability A intersection B given probability of B. So whenever A and B are independent, probability of A into probability of B given probability of B. So this and this goes, we will be left with probability of A, that's equal to, that's only this term. Then we have the expectation of this. Clear? Actually, the PDF will be probability of x1 multiply probability of x1 minus x2 given probability of x1 minus x2. So this and this goes, we will be left with probability of x1. Then we have to find the expectation of 1 by theta x1 minus 1 upon n. Clear? So now x follows Laplace distribution. Then we have f of xx is equal to e raised power minus x minus 2 theta. From here, as you know, x minus 2 theta will follow exponential 1 upon n. So see, from here x1, expectation of x1 will be equal to, this is 1 upon n plus 2 theta. This is exponential n. So this will follow exponential n. Then expectation of x1 is equal to 1 by n plus 2 theta. From here, this is also equal to x1 minus 1 upon n is equal to 2 theta. That's expectation of this is equal to 2 theta. So we get the value of this. So see, x1 minus 1 upon n, this expectation of x1 minus 1 upon n is equal to 2 theta. So expectation of 1 upon theta into 2 theta is equal to expectation of constant is constant, that's 2. I hope you remember this and you got this, okay, how it's equal to expectation of 1 by theta x1 minus 1 upon n is equal to 2, is equal to